Hey everyone, welcome to GradeGetter. My name is Taylor, and today we are starting another new series of videos that I hope will be really helpful for you all. We are going to work through a practice test for the ACT. Specifically, this practice test will focus on the math portion for the ACT, and I think it will really help you get a feel for what kind of questions will be on the test and how to study for it. Alright, let's make the ACT make sense. As you probably know, the ACT is a comprehensive test made up of 4 different sections: reading, English, math, and science, with an optional 5th section for writing. In this video series, we're going to take a look at the entire math portion of the test and work through all of the problems together. Now, this practice test is modeled after the actual ACT, so although the questions will be a little different, the concepts will be exactly the same. Now, as a very brief introduction, the ACT math test is made up of 60 questions that you have to complete in 60 minutes. So on average, you have about 1 minute per question. Now, if that doesn't sound like a lot of time to you, don't freak out. Some questions are easier than others, and other questions are actually related to each other, which means they use the same material or data. For instance, one graph or picture may actually be used to solve several problems in a row, so you won't have to solve an entirely new problem with completely new information every time. Now that we've covered some of the basic expectations for the ACT math test, let's go ahead and start working through these problems together. And for you to get the most out of this series, we're going to take our time working through each problem so that you not only know how to solve the problem, but also the concepts that are important. This will help you know which concepts you are good at and which ones you need to spend more time on as you study and prepare for the test. Let's get started. Alright, here we go. Question number 1 gives us some information and then a graph that goes along with the information. So that's all this section right here. And it says that students and adults from Western High School visited an amusement park on a field trip. The amusement park charged $25 for each adult ticket and $20 for each student ticket. Before the trip, the students were given this information about the Happy Dragon roller coaster. The average speed of the roller coaster is 50 miles per hour, and one ride on the roller coaster track is completed in 2.25 minutes. A graph showing the height above level ground in feet with respect to the time into the ride in seconds is given below. So we're given just a ton of information, and then we're given this graph. And now finally, they ask us a question related to this information and graph. So it says, which of the following values is closest to the total distance traveled in miles during one complete ride on the roller coaster track? Okay, so one strategy that I like to incorporate when solving math problems, specifically word math problems, is using the find given technique. And this is really helpful when you're given just a ton of information like in this problem. So I like to write down literally what I'm supposed to find, and then given information that could potentially help me solve what I'm trying to find. So what I'm trying to find for this first problem is the total distance traveled in miles during one complete ride. So I'm going to write that down. Now, the reason for doing this is to really help you stay focused on what you're trying to solve for. We're given a lot of information here, and this will kind of help me figure out what I need to write down for my given. So helpful information that they give me. Obviously, the stuff about money, right, that's not going to help me. So I'm not going to write that down. However, they tell me the average speed of the roller coaster is 50 miles per hour. So that seems like some helpful information. I'm going to write that down. So I'll place that under my given here. And then they also tell me that one ride is completed in 2.25 minutes. So I'm going to write that down as well. So that pretty much captures all the useful info from this paragraph. Now I need to consider if I need to use this graph to help me solve this problem. So this graph gives me the height of the roller coaster above the ground as a function of time. So this height is dependent on the time. And based on what I'm trying to find here, the total distance traveled, doesn't seem like this information will be useful for this problem. So I think I've captured enough info here. Let's see if I can use this information to solve my problem. So if my roller coaster is traveling at 50 miles per hour and one entire ride takes 2.5 minutes, let's see how many hours 2.25 minutes is, right? And the reason I want that is because I've got hours here in my speed. So a big kind of caution to you is you want to make sure you're working with same units. So if you have different units for time, you're going to want to try and get the same units. In this case, I'm going to try and convert all of my time to hours. So anything that's in minutes or seconds, I'm going to convert to hours. So to convert 2.25 minutes to hours, I'm going to use a conversion ratio, which shows how many hours there are in minutes or how many minutes there are in hours. In this case, it's easier to do minutes in hours. There's 60 minutes in 1 hour. So this is our ratio of hours to minutes. And the reason I want minutes to be in the denominator is so that it cancels out with the minutes in the numerator here. Because minutes over minutes cancels out, and I'm left with hours, which is what I'm trying to solve for. So we're going to multiply 2.25 times 1 over 60. So to do this, we could recognize, I can write 2.25 as a fraction with just a denominator of 1. And then when you multiply fractions, you multiply straight across. So numerator multiplies times numerator, denominator multiplies times denominator. So my answer is going to be 2.25 times 1, which is 2.25, over 1 times 60, which is just 60. And my units, again, is hours here. So it's 2.25 over 60 hours. Now we can use our calculator to solve for this. Now I've brought my calculator up here, which is a good time to give a statement about what kind of calculators you can use on the ACT. Now the good news is you can use a graphing calculator. For instance, the TI-84, which is a common graphing calculator, is allowed on the ACT. However, you cannot use a calculator that has a computer assisted system, a CAS. Most common calculators that use that are the TI-89. So if you are using a TI-89, if that's something you're familiar with and you like to use, you are not allowed to use that on the ACT. In fact, that's one of the main reasons why students are excused from taking the ACT, is because they brought a TI-89 into the test, which you're not allowed to do. So make sure you get a TI-84 or some other calculator that you would prefer to use that does not have a CAS system. I'm just going to use the Windows application calculator app to solve this problem. So 2.25 divided by 60 equals 0.0375. So if one ride takes 2.25 minutes, that's the same thing as 0.0375 hours. Now remember, we're trying to find the total distance that this roller coaster has traveled. So when you multiply a speed times a time, you're going to get a distance. So let's multiply 50 miles per 1 hour times 0.0375 hours. Again, you can see why we converted our minutes into hours, because I want to have the same units of hours and hours. Again, we're going to multiply fractions, which multiply straight across. So 50 times 0.0375 over 1. And the hours will cancel out. So we're left with just miles. So 50 times 0.0375, let's bring up our calculator again, equals 1.875. And the units for this again is miles. So this is going to be our final answer. This is the total distance traveled during one complete ride. Now let's look at our answers over here. And it asks which one is the closest, which value is the closest to the total distance traveled. And it looks like B is going to be the closest, right? If we rounded up our answer to the 10th decimal place, it would be 1.9. So B is our final answer. We've got a couple more problems to solve, but before we move on, I just wanted to let you know that GradeGetter offers a whole series of videos that focus on the math portion for the ACT. So if you're looking for helpful tips to boost your score, then be sure to like this video and head over to our website at GradeGetter.com. We are here to help you get the grade you want and to make the ACT make sense. Now back to the video. Alright, for question number 2, we're going to actually use the same information and data from question number 1. So again, we don't have to rehash everything. Instead, let's just talk about what we're trying to find from this question. It says the roller coaster is at a height of at least 235 feet for a total of 5 seconds during each complete ride. Which of the following is closest to the percent of the time during a complete ride that the roller coaster is at a height of at least 235 feet. So that is what we're trying to find. So this is how I've worded it. It's a percent of time when the height of the coaster is greater than or equal to 235 feet. Because that's what it means when it says at least 235 feet. So when h is greater than or equal to 235. Next, let's write down what we're given. Well, it actually tells us how long the roller coaster is at a height of at least 235 feet. See, it says here at the start that it's at a height of at least 235 feet for a total of 5 seconds. So I'm going to write that down. So if it's at this height for 5 seconds during the whole ride, how long is an entire ride? Well, they also give us that information up at the top. They say that one ride is 2.25 minutes. So I'm going to write that down as well. Now you might be thinking, I don't have time to write all of this down if I'm taking the test. If I only have 1 minute per question, by the time I write this question, I've already used up a whole minute. Well, remember, the point of this video series is to slow down and take our time working through the concepts so that you can study them as you prepare for the test. Also, you can be doing some of this in your head. Like, you don't have to write down all of the given information, but you should be at least underlining or highlighting what information is helpful for this particular problem. And honestly, I also would really recommend, at least on these long word problems, writing down what you're supposed to find. That really won't cost you too much time, and it helps you really focus in on what you're looking for in this particular problem. So I think it's worth writing down what you're supposed to find, and I think it will actually save you time in the long run. So if our roller coaster is at 235 feet for 5 seconds, and the total ride is 2.25 minutes, then 5 of the seconds out of the 2.25 minutes, this roller coaster is above or at 235 feet. So we kind of have our information here. However, we have different units. So I'm going to convert my minutes to seconds. That way we're talking and comparing seconds to seconds. So let's go ahead and do that. So to convert minutes to seconds, we'll again use a conversion ratio, which says there are 60 seconds in 1 minute. And again, I know my minutes goes in the denominator for this conversion ratio because I'm trying to cancel out the minutes here in the numerator, which will just leave me with seconds in the numerator. So my minutes will cancel out, and I can multiply 2.25 over 1 times 60 over 1. Fractions multiply straight across, so 2.25 times 60 over 1 times 1. I'll bring up my calculator again. So 2.25 times 60 gives me 135 seconds. So the total ride is 2.25 minutes or 135 seconds. Now we have enough information to solve this. So for every 5 seconds out of the total 135 seconds, our roller coaster is at 235 feet or higher. So this is our percentage, but it's only in decimal form, right? If I type this into my calculator, 5 divided by 135 gives me 0.037, and I think it keeps repeating. 0.037037. Repeating. Now, to convert a decimal into a percentage, you just multiply by 100, which means you move your decimal 2 places to the right. So as a percentage, this is 3.7037, where that's repeating percent. So looking at our possible answers here, 4% is going to be the closest, which is what it's asking. It says, what is the closest to the percentage? So if we round 3.7 to the nearest percentage, it's going to be 4%. All right, question number 3 is also related to the previous 2 questions, in that it's using the same information and data here. So let's just take a look at our question and what we need to find. It says, which of the following values is closest to the average slope in feet per second of the graph on the interval between 40 seconds and 90 seconds. So it looks like we'll finally get to use the information from this graph here. And so what we want to find is the average slope in feet per second of the graph on the interval between 40 seconds and 90 seconds. So I've written that here, or you could also say the interval of 40 to 90 like this, where t is in between 40 and 90. Now, our given information is really all captured here in this graph, so I'm not going to redraw that. However, I do want to write down one thing, and that is the equation for the slope. So this may be a refresher, and if it's something that you totally forgot about, this is a good idea to go back and study this concept. But the equation for slope between 2 points is the difference in y over the difference in x. So you can write it like delta, meaning the symbol for the difference or the change in y over the change in x. So we need the coordinates for 2 points. So let's look at our graph and see if we can figure out what our 2 points are going to be. Ideally, you want to pick points that are easy to identify, that fall hopefully on a nice little line for us. So right here, this would be 90. So this falls within our interval. So t equals 90, and let's see, the height would be, I think, 250. So I'm going to write that point down. So our xy for this point is going to be 90, 250. And let's pick out our second point. Our second point is going to be a little tougher because it doesn't seem to fall perfectly on a point. I see two potential options we could use. We could say 70. Oh no, I thought that lined up with 150. But that doesn't seem to do that. Well, we could do maybe this one, 80 and about 200. So let's try that for our second point. So our second point here is going to be 80, 200. So using our slope formula, we're going to do the change in our y's divided by the change in our x's. So it'll look like this. So 250 minus 200 over 90 minus 80. Now what's interesting is it doesn't really matter which one is our x2, or I'm sorry, which one is our x1, y1, and which one is our x2, y2. I could flip both of these, right? So I could have done 200 minus 250 over 80 minus 90, and I still will get the same answer. So don't overthink that too much. So 250 minus 200 is 50, and 90 minus 80 is 10. Now, when I reduce this answer, I get 5. And if I go look at my option of choices, I don't see a whole lot of helpful choices. Maybe this last one is 4. So I think I'm going to try and pick a different point and test that out. I'm going to keep my same point here at 90, 50. However, my second point, I think I'm going to try here. I'm going to try at we'll call this 40, 50. And I'll plug these points into my slope equation again and see what I get. So I've got 250 minus 50, that's the difference between our y coordinates, and then 90 minus 40, which is the difference between our x coordinates. So now let's simplify. 250 minus 50 is 200. 90 minus 40 is 50. Now if we simplify this, 5 goes into 20 4 times, which is much closer to our actual answer. So it seems like we had made an educated guess with the point that we chose before, right? None of the other ones were really close, and now we picked a different point just to double check, and we get seems a more accurate answer. So I'm going to say E is the correct answer for the average slope between the intervals from t equals 40 to 90. Congratulations, you have just solved the first 3 problems for the ACT Math practice test. We're going to keep chipping away at these problems, so be sure to watch the next video in the series and subscribe to the channel so you stay updated on all of our content. Thanks for watching, and until next time, God bless.